Hey, I'm back.
Hey.
What's wrong?
Well, I found a clue, I guess, and let me to this other one, and I don't know what this one means or where either of them came from.
Well, what do they say?
Well, the first one says, if you make food in this room, then you will find your next clue in it. And then the second one says, if you find me by the pond, then fish will swim in it. How does that even make sense?
Hang on a sec. Let me see those. I know what these are.
What are they?
Conditional and converse statements.
What?
Okay, so a conditional statement is the most basic kind of statement. If P, then Q.
P and Q? What do those stand for?
Well, P stands for the hypothesis, and Q stands for the conclusion.
Well, why P and Q? Wouldn't it make a lot more sense for it to be H and C or something like that?
I don't know. Those crazy math people come up with all sorts of weird stuff.
Yes, that makes a lot more sense. Anyways, what does the second one mean? Oh, so intelligent, Brittany.
Okay, so the second one is a converse, which means that the Q and the P are switched. So it says, if Q, then P.
So if the second one is a converse, then the conditional of this one should be, if fish swim in it, then you will find me by the pond.
Exactly. That makes a whole lot more sense than fish magically appearing whenever you stand next to it.
Yeah. Sorry to interrupt, but I just want to answer the question that I know you're all thinking right now. How does this have anything to do with math? Well, I'm about to make that connection for you. We are going to use an example that actually has to do with math. So if you take a P and a Q, it makes conditional statements, you know. If P, then Q. So if two segments are congruent, then they have equal measurements, which would be a conditional statement, right? Pretty simple. Okay. If you take your P and your Q and you flip them up, and you have if Q, then P, you would have, if segments have equal measurements, then they are congruent. So it's still the same statement, you just flip the P and the Q. We got these two little guys right here. They're invisible, I know, just bear with me. But you know, if you do that, then, hey, it makes sense. So, I'm just gonna leave you alone now and let you continue to watch the video. Enjoy. So, should we go to the pond?
I don't know.
I mean, what if there's some psycho serial killer who put these in our house so he could get us to go to the pond where he could slaughter us and easily dispose of our bodies there?
Well, then we should just bring some mace. Come on, let's go. Don't be such a baby.
Fine, but I get the mace.
Deal.
Let's go. I'm freezing. We shouldn't have even come out here.
Where's your spirit of adventure? Besides, we're almost there.
My spirit of adventure already froze to death. Hello? Mr. Mathman?
Why, I'm right here!
Ah!
Fish are coming, my friend.
Where did you come from? Oh my gosh. Well, we came because of the clues that you left in our house. Was that you?
Fantastic.
Okay. Well, what do you want?
If I do not tell you, you will not learn.
Okay, so why don't you just tell us? Oh, he's still talking in different kinds of statements.
Well, I'm glad you figured that out, because I thought he was just trying to talk like Yoda.
I think he was talking in an inverse statement.
Right, you are my friend.
So, is an inverse statement just if not P, then not Q?
You catch him so fast. Isn't she doing well, Brittany?
How do you know my name? Maybe you were right. This guy's crazy.
Told you so.
My friends, if you do not learn, then I will not tell you.
What does that have to do with anything?
Wait. I'm me guess. This is another type of statement.
Right again, my friend. Control positive. If not Q, then not P. But it's still a false statement.
Okay. I am back again. First to say that this guy is crazy. Also a nut job. Kind of weird. Scary. Anyways, second of all, he isn't the best at explaining math statements because he's kind of confusing and he talks really fast and weird. So we're going to do as we did earlier and relate them back to math statements. So as you learned, an inverse statement is just if not P, then not Q. So if we take the statement that we used earlier and made it an inverse statement, it would be if segments are not congruent, then they do not have equal measurement. Pretty simple, right? And then a contrapositive, we do the same thing, and we just flip up the Q's and the P, and then you have if not Q, then not P. So it would be if segments do not have equal measurements, then they are not congruent. It's pretty easy, and I hope that helped, because this guy is weird, as I said earlier. Now let's go see what this weirdo is here for, and what he is going to do. Can we go home now?
Wait! We're not done learning yet.
Haven't we learned enough pointless information for today?
Pointless information! That's what you call pointless information! I think you two are the crazy ones.
Okay, well, haven't we learned enough savory information for today?
Why no?
What's next?
Well, do you remember what conditional and converse statements are?
Well, considering that I learned that less than 20 minutes ago, yes, I do.
Well, Miss Noda, you need to remember those two for the final lesson.
Okay.
Hallelujah, we can almost go home.
Are you kidding me? You are the one who dragged me out here.
I dragged you?
Ladies, calm yourselves down. My conditionals will solve all of our problems.
What's wrong with you?
Nothing, my friend. If you have an open mind, then you'll be more accepting. It's contrapositives. Isn't it great?
Okay, but isn't that just a conditional?
Well, it is. But it's also true as converse. See, look. If you're accepting, then you have an open mind. See, they're both true, which makes it bi-conditional statement.
Alrighty then.
So, I am back again to ruin this video with more math explanations. Stinks, I know, but that's the whole point of this video. So, as this nut job was saying, a biconditional statement is just a statement where the conditional statement and the converse statement are both true. And the example we used earlier just happens to be a biconditional statement, because if segments are congruent, then they have equal measurements, and if you flip them, if segments have equal measurements, then they are congruent. Just both happen to be true. So it works out great. But there are statements that are conditional and converse that are not both true. So for example, if two angles are vertical angles, then they are congruent. That makes sense as a conditional statement, right? But if you take the P and the Q and you flip them around, then you have if two angles are congruent, then they are vertical angles, which is not always true, right? So that doesn't make it a biconditional statement. So I hope that makes sense. My best advice for you is just mind your P's and Q's. Get it? P's and Q's. If Q, then P. If P, then Q. Alright, anyways, I'll let you finish up this video now. So, I hope you like the great ending. This adventure was a waste of time.
Wait! There's a treasure waiting for you at the parkway over there. And since you have learned, you may now go get it.
What is it?
I'm telling you, go find out.
I love surprises.
Do we have
Yes.
to?
We are gonna go get our treasure.
Yay! Let's go.
Well, where is it?
I don't know. What are we even looking for, anyways?
I don't even know.
Hello, my girls.
Oh
my gosh. Wow, how did you get here so fast?
Magic, lady.
What's our prize?
I'll be right back. Here you go, big one. Here you go.
A successful math learner certificate?
Yes.
Are you kidding me?
No.
I told you this was a bad idea.
Maybe next time we can talk about orthos. If they don't love math now, they'll love math later.